Hello warriors, this is Miss Lemons, and today we're going to be going into even more complicated conversions with moles. Today we're going to be focusing on diatomic molecules. So you're going to need a calculator, your periodic table, a pencil, and your mole concept packet. Looks like this. If for some reason this video is going a little too fast for you or you're feeling a little lost, make sure that you are able to do the earlier practice problems in this packet because they are simpler. I've also created videos for each section of this packet, so feel free to re-watch those if you need to refresh your memory before you get to these more advanced problems. All right, so practice number 33. How many moles of bromine gas are in a 7.28 sample of molecules of gas? So we are starting with 7.28 times 10 to the 28th molecules of gas, and it's asking me to figure out how many moles of gas are in there. Now we need to pick out a conversion factor. Remember, the conversion factor needs to contain the unit molecules and moles if we are going to use it. So let's look at what we have available. We have the molar mass, which goes from moles to grams, or grams to moles. And we have Avogadro's number, which goes from moles to particles, or particles to moles. Now, neither of those sound like they go to molecules, but remember, particles can be atoms, ions, or molecules. So replace that in your head. 1 mole to particles, or 1 mole to molecules. We are trying to go from molecules to moles. Avogadro's number is exactly what we're looking for. Now, the nice thing about Avogadro's conversion factor is that the numbers have already been given to us. All we have to replace is the x, and we're going to replace that with Br2. So this is what our conversion factor looks like. Now that I've got everything set up and ready to go, I can put together my mathematical setup. So we're always going to start with what we know over 1. So that is 7.28 molecules of Br. And you should really be careful. So that's 7.28 times 10 to the 28th power. And I'm going to write out the whole world molecules because a lot of us are going to abbreviate it and it's going to look like this, mole. And that's not good because obviously a mole is an actual unit. So yes, I'm going to take the time to write out the full word molecules. And it seems a little tedious, but it's going to prevent you getting confused with your units later on. Now I know I'm going to multiply that by a conversion factor. That conversion factor, we need to look at what we picked out, which was 1 mole of Br is equal to 6.02 times 10 to the 23rd molecules of Br. What's on top must come down. So if I have molecules of Br on top, I know I need molecules of Br on the bottom. So I'm going to go ahead and write down my unit. How many molecules of Br? Well, look at your conversion factor. It's not 1 because that's just moles, so it's got to be 6.02 times 10 to the 23rd molecules. Okay, so now that I've gone ahead and put down my bottom one, my denominator, I know that I've used 1/2 of my conversion factor. Once you use 1/2, you have to use the other half on top. So that would be 1 mole of Br2. Last but not least, we are going to go ahead and solve. Multiply your numerators together to get a new numerator, and your denominators together to get a new denominator. So that would be 7.28 times 10 to the 28th power times 1 is itself. So that's 7.28 times 10 to the 28th power. And then 1 times 6.02, that's going to be the same as well. So 6.02 times 10 to the 23rd power. Now, when we plug this into your calculator, you need to be really careful. Want to make sure that you put parentheses around each of your scientific notation terms, because if you don't, you'll get a wrong answer. And this is because your calculator is using the order of operations, so it's PEMDAS. We want to make sure that it's calculating the exponent first and then dividing the two numbers. So we're going to prevent any issues by just using parentheses. Okay, so now that I plug this into my calculator, the raw number that I end up getting is 19,324,651. Now this seems like a really large number, but if you think about it, you're taking a super large number divided by a pretty large number, so you're going to end up with a pretty large number. And last but not least, we need to round according to the rules of sig figs. We started with 3 sig figs, so we need to end with 3 sig figs. Underline your top 3 place values, and then round. Because this 2 is less than 5, our final answer is going to be 19,300,000 moles of Br2. Or, if you'd like, you can also convert this to scientific notation. So I'll just do a quick refresher of that. If you want to convert to scientific notation, you're going to take that decimal that's not there, and you're going to move it 1, 2, 3, 4, 5, 6, 7 spaces to the left. So I'm going to take 1.93 times 10, and I moved it 7 spaces. And because I was creating a very large number, it would be a positive value for our exponent, which is why it's positive 7 and not negative 7. So that would be, again, molecules of Br2. Either one of these answers is acceptable. They are both rounded according to the rules of sig figs, even though they're in 2 different types of notation.